Alright, so we're going to continue with our look at matrices and determinants. We have learned how to find a determinant for a 2 by 2 and a 3 by 3, and now we're going to learn how to use determinants to solve a system of equations. And we're going to use something called Cramer's rule. So we'll start with Cramer's rule for a 2 by 2 system, meaning ones that look like this. Okay, so we did initially algebraically substitution and the elimination method. Now we're going to use the determinants. Alright, so as long as the determinant is not equal to 0, because I can't divide by 0, we are going to take the coefficients and make a coefficient matrix. So it'll look something like this, initially as A, B, C, D. So in order to solve for the solution of a system, meaning where the two lines intersect, for the x variable, what I'm going to do is I'm going to first find the determinant of the coefficient matrix. That's what's going to go down here. Okay. Then I am going to replace the variable that I want to solve for with what the equation, the system, is supposed to equal. So in this case we call that E and F. And I find that determinant and then divide it by the determinant of the coefficient matrix. And then when I want to find y, I'm going to put the E and F in the place where the y variables would go. So I think the best way to understand that is to kind of see me do one. Okay, so let's look at example 4, and we're going to look at A. So first, my coefficient matrix is just 9, 4 for the first one, x, y, and then 3, negative 5. So I want the determinant of that. Oops, sorry. Which is 9 times negative 5 is negative 45, minus 4 times 3, which is 12. This gives me negative 57. Alright, so now what I'm going to do is I'm going to kind of ignore this for the moment, and I'm going to go over to the side here, and I'm going to start with finding the x solution. Alright, so I'm going to replace the 9 and the 3 with negative 6 and negative 21. So I want the determinant of negative 6 and negative 21, and then I'm going to leave the 4 and the negative 5 alone, whatever that determinant is, divided by negative 57. Alright, so I'm going to get negative 6 times negative 5, which is 30, minus 4 times negative 21, which is negative 84. So I basically have 30 plus 84 divided by negative 57, and that's going to give me negative 2. So x is equal to negative 2. Okay, now the y variable, instead of replacing the 9 and the 3 this time, I'm going to replace the 4 and the negative 5 with the negative 6 and the negative 21. And divide that determinant by the negative 57. So I've got 9 times negative 21, which is negative 189, minus negative 6 times 3 is negative 18, so that's going to become plus 18 over negative 57, and I get 3. So my point of intersection, my solution to this one is negative 2, comma 3. I'm going to do one more for you, and then you'll try the last one yourself. Okay, so I'm going to find the determinant first of the coefficient matrix. That's 15 minus negative 4 times 2, so it becomes plus 8, and I get 23. Okay, so now my solution for x, replace the x variables with the solution. So that's going to be negative 15 and 13, and then negative 4 and 5, and I'm going to divide that answer by 23. Alright, so I've got negative 15 times 5, which is negative 75. Negative 4 times 13 is negative 52, so it's going to be minus a negative 52, or plus 52. Negative 75 plus 52 is negative 23. Divided by 23 is negative 1. So my x variable is negative 1. All right, so y is going to be replacing not the x pieces, but the y pieces with the negative 15 and 13, and dividing that by 23. So I get 3 times 13 is 39 minus a negative 30, so it's going to be plus 30. And when I do that, I get 3. So my solution is negative 1, comma 3. A little bubble is going to show up now for you to try C yourself. All right, so now let's look at it. The rules still apply the same way for 3 by 3. It just gets a little more, because you have 3 variables, so you're going to have to do this 3 times, 3 determinants, and all that good stuff. So for this first one, I'm going to look at example A, and I'm going to do my coefficient matrix up here. So I need to do for 3, negative 4, 2, and then 4, 1, negative 5, and then 2, negative 3, 1. So remember, I take the first 2 rows and I copy them back outside so that I can go on the diagonals. So I'm going to have 3 times 1 times 1, which is 3, plus negative 4 times negative 5 is 20, times 2 is 40, plus 2 times 4 is 8, times negative 3 is negative 24. And I'm going to subtract from that going the opposite way. Let's do another color here. 2 times 1 times 2 is 4. 3 times negative 5 is negative 15, times negative 3 is 45. And negative 4 times 1 is negative 16. So when I do all of that, I get out negative 14. Okay, so now for my x solution, I'm going to replace the x variables with the solution. So I've got 18, negative 13, and 11, and then the y and the z stays what it was. I'm going to divide that by negative 14. So if I go to do the determinant, I'm going to rewrite this stuff outside, the first 2, so that I can do my diagonals. Okay, so I've got 18 times 1 times 1 is 18, plus negative 4 times negative 5 is 20, times 11 is 220, plus 2 times negative 13 is negative 26, times negative 3 is 78, minus, now we go the other way, 2 times 1 times 11 is 22, plus 18 times negative 5 is negative 90, times negative 3 is 270. I ran out of room. Negative 4 times negative 13 is 52 times 1, so that's 52. So I've got all of that divided by negative 14. So 18 plus 220 plus 78 is 316, minus 22 plus 270 plus 52 is 344. So I've got 316 minus 344 is negative 28, divided by negative 14, and I get x equals 2. So I got to do this 2 more times. So now for my y variable, I'm going to leave the x's what they were and the z's and replace the y variable with the solutions. And divide that by negative 14. So again, I got to copy the first 2 columns here so that I can do my determinant. Alright, so I've got negative 39 plus 18 times negative 5 times 2 is negative 180 plus 8 times 11 is 88 minus, now we go the other way, 2 times negative 13 times 2 is negative 52 plus negative 15 times 11 is negative 165 plus 18 times 4 times 1 is 72. All of that divided by negative 14. All right, so negative 39 plus negative 180 plus 88 is negative 131. And then negative 52 plus negative 165 plus 72 is negative 145. So that's going to become plus 145. So I've got negative 131 plus 145 is 14 divided by negative 14 is negative, oop, that should be a y, not a z, is negative 1. One last time. So now I'm going to replace the z variable. So y, x and y stay what they originally were. And I replace the z variable. So again, I'm going to copy the first two columns so I can find my determinant and start multiplying. That's an 11. All right, so I got 3 times 1 times 11 is 33 plus negative 4 times negative 1. Okay, so I'm negative 4 times negative 13 times 2. Right, so negative 4 times negative 13 times 2 is 104. And then 18, 4, and negative 3. 18 times 4 times negative 3 is negative 216. And minus, let's go the other way, 18, 1, 2. So that's going to be 36. 3, negative 13, negative 3. So I've got negative 9 times negative 13 is 117. Plus negative 4, 4, and 11. So negative 16 times 11 is negative 176. All right, so 33 plus 104 minus 216 is negative 79. 36 plus 117 minus 176 is negative 23, so that's going to become minus a negative, so plus 23. So negative 79 plus 23 is negative 56 divided by 14 is negative 4. So I get my x value, which we determined was 2, my y value, which is negative 1, and z, which is negative 4. And there's my solution. So again, you're going to have a pop-up window for the last one for you to try on your own.